You might have heard about hydrocarbons. Hydrocarbons are series of compounds that contain mainly carbon and hydrogen. There are saturated and unsaturated hydrocarbons. Alkane, as a saturated hydrocarbon, contains single bond between the carbon atoms, and it has the general molecular formula of CnH2n plus 2. That's where you have methane, which contains one carbon atom, ethane, which contains two carbon atoms, and so on. How are they prepared? Number one is through the hydrogenation of alkenes or alkyne. Alkene and alkynes are converted into alkenes by adding hydrogen in the presence of a catalyst such as nickel, platinum, or palladium. And this process is called catalytic hydrogenation. Process you have the ethene reacting with hydrogen to give ethane. Another reaction is Wood's reaction. In this method, the alkyl are treated with sodium metal in presence of dry heater, resulting in the formation of a longer chain alkane. The reaction involves the coupling of two alkyl, like for example, the reaction of bromomethane to give ethane. The third is the decarboxylation of carboxylic acid, where the carboxylic acid or the salt of carboxylic acid, such as sodium carboxylate, are heated in soda lime. Soda lime is a mixture of sodium hydroxide and lime itself, as calcium oxide, resulting in the formation of a carbon atom as carbon 4 oxide, leaving behind an alkane. The example is the reaction of sodium acetate in the soda lime, that sodium hydroxide heated along with calcium oxide to give methane. Then the electrolysis of an aqueous solution of sodium or potassium salt of carboxylic acid produces an alkane. This process involves decarboxylation at the anode. An example is the electrolysis of sodium acetate to ethane. Alkene, as an unsaturated hydrocarbons, which has the molecular formula of CnH2n, can be prepared by the following method. One is to dehydrate alcohols. Alcohol can be dehydrated by the removal of water molecule to form alkenes. This process is typically done using concentrated sulfuric acid or alumina as a catalyst. It's done at a particular temperature where ethanol in this case gives ethene. Another method is dehydrohalogenation of alkyl. When alkyl is treated with a strong base such as alcoholic potassium oxide, which removes a hydrogen atom or a halogen atom, resulting in the formation of an alkane, which is an elimination reaction. That's an E2 mechanism. An example is the dehydrohalogenation of alkylate. An example is the dehydrohalogenation of bromoethane to give ethene. Another method is cracking of alkanes. Long chain alkanes can be broken down into shorter alkanes and alkenes by what we call thermal cracking. That's the heating. In industrial process, cracking is an important method for producing alkenes. That's, for example, hexane being cracked to butane and ethene. Another method is dehalogenation of vicinal dihalides. Alkenes can be prepared by removal of halogen atoms from vicinal dihalides, that's compounds with two halogen atoms on adjacent carbon atoms, using zinc metal in the presence of an acid. That's the 1,2-dibromoethane being converted to ethene. How can alkane, which general molecular formula CnH2n-2, is prepared? Similar to what we just talked about in alkane, it it's also dehydrohalogenation of dihalide to give alkyne. And example is 1,1-dibromoethane to give ethyne in alcoholic potassium hydroxide. Also, another method is partial reduction of alkynes. Alkynes can be prepared by partially reducing tetrahalides using zinc dust of acetic acid. This process involves the selective removal of two halogen atoms to form alkyne. As for example, such reaction involved tetrabromoethane to give ethyne. Geminal dihalides simply means where two halogen atoms are attached to the same carbon atoms, and they can undergo their hydrohalogenation to yield alkyne when treated with a strong base. The method of deriving alkyne from calcium carbide. Alkynes, particularly acetylene, which is ethyne, can be prepared industrially by the hydrolysis of calcium carbide, by reacting calcium carbide with water to produce ethyne and calcium hydroxide. I hope you find this helpful. Thank you very much.